Hello, waves number 9, beats. What are beats? Well, beats are produced when you have two waves that are very similar in frequency and amplitudes, and they're interfering with each other, so they're superimposed. So you might have two sound sources producing similar frequencies, is a common example, and we'll demonstrate this in class. And what you get is you get a regular pattern of constructive and destructive interference as these two waves interfere with each other. But the pattern produces an intensity in the wave, the resulting wave. The intensity varies. And so you get an interfering, like if it's two sounds interfering, you get a variation going from loud to soft, loud to soft, loud to soft. That's independent of the two other sounds. And that frequency of loud to soft is called the beat frequency, and it's determined by the difference in the frequencies of the two waves that are interfering. Okay, so the frequency of the beats is equal to the separation in the frequencies of the waves. And we have this little formula here, F beats equals F2 minus F1. Pretty straightforward. So here we have two waves, frequency 12 Hertz, frequency 15 Hertz. So what we should get is a beat frequency of 3 Hertz. And this is what they were trying to show here. Now, it's not a standing wave. It's a waveform, and so if we had a time scale and we move the time scale through this, you would get a loud sound, then a soft sound, then a loud sound, then a soft sound, then a loud sound, then a soft sound. And that resultant beat frequency is 3 Hertz. And we'll show that. It's a bit hard. It looks like a standing wave, but it's not a standing wave. We're going to show that to you shortly with a web page, I think. And this is just another one. So you're getting constructive interference here, producing supercrest, supertrough, and then destructive interference. And we get this regular pattern of constructive, then destructive, then constructive, and destructive. Okay, so let's go to the web page and we'll see if we can actually get it to work. Alright, now, so what we're going to do is produce beats here of 1 Hertz, so you're going to have to listen very carefully, and I'll try and not have the temptation to talk over the top of it. And we've got two frequencies interfering, 400 Hertz and 401 Hertz. This would be the resultant wave, and this is what it looks like, and this is what we're actually playing. And so you should hear a beat frequency, loud, soft, once a second. Got that? Now let's just vary that a little bit. So what we're going to do in this case is they're going to actually increase the higher frequency, and it's going to increase gradually. So we go from beats of 1 Hertz up to 10 Hertz. So the beat frequency will increase. You've got to listen fairly carefully to this, but this happens. So you get that. So we started off at 1, and because they were increasing the higher frequency, the number of beats changed. We might just listen to that again. Alright, and so we'll demonstrate that with a couple of speakers and an audio generator. Let's go back to the PowerPoint now. Okay. So recognizing that this is not a standing wave, it's actually the wave pattern that's moving, and so that's what we get. So you should be able to do these questions here, and the next video is going to be on resonance. See ya.